Thank you for joining our June learning series. Today's topic is going to be around I/O devices and just a little general update and portfolio kind of refresher on Rockwell Automation's I/O platforms. Somewhat straightforward topic today, and probably we're not going to really deep dive into too much, but just a general review of what we got out there, and in case you haven't kept up with things. My name is Wayne Welk, automation specialist out of New Orleans. I'm just going to kind of kick things off. I'm going to turn it over to two of our other specialists here momentarily. So let's go through our kind of standard slides here. Throughout the year, we do these learning series, online learning series topics monthly. And here's the remainder of our schedule for 2024. Today, of course, is June and I/O devices. Next month, we will do an Edge Analytics update, then a process update in August, and drives update in September. And rounding out our learning series, topics will be an Automation Fair preview there in October, because Automation Fair is coming up soon. We as we said before, we record these sessions. Those sessions being recorded, we make them available afterwards, so you're welcome to come back and rewatch or share them with your colleagues if there's a topic of interest. Today, our guest presenters are going to be Neil Kaczynski with the Reynolds Company out of San Antonio, and Mark McGinnis, our specialist up in the Dallas-Fort Worth area. But before I turn over to those two guys, we mentioned Automation Fair, so it is time to start thinking about it and planning for it. Automation Fair is going to be in Anaheim, California this year, and the dates are November the 18th through the 21st. If you hadn't seen the change to Automation Fair that came about last year, they've extended the event to be a 4-day event. This year, the big change is the expo, the floor show, will be available and open from Tuesday through Thursday. Traditionally, that's been 2 days, Wednesdays and Thursdays. Now they've extended to Tuesday as well. The additional Monday there will be things like offsite tours and some advanced training opportunities, as well as some general access sessions. So that Monday is a very useful day as well. So the other change that happened about last year, if you weren't familiar, was there is a charge now to attend Automation Fair. There's a general access as well as a advanced training option. So take a look at that, those dates, and reach out to your automation specialists in your territory or your account managers, and we're always happy to help get you comfortable and familiar with what's happening at Automation Fair. And with that, I'm going to turn it over to Neil. Neil will start our presentation here on I/O devices.
Great, thanks, Wayne. Starting off with chassis-based I/O systems for remote and distributed I/O applications. Our standard PLC families, the control logics and both variants of the compact logics, also offer communication adapters to enable remote I/O on these common I/O platforms. All three offering different rangings of I/O types and specialty I/O. The control logics obviously would still maintain your typical control logic system components like the chassis, I/O modules, and power supplies. Similar with the 1769, using the AE and TR network adapter and 1769 I/O. And then our latest of the compact logics, the 5069, offers network adapters to utilize those I/O module families and remote I/O applications. Noting on the 5069 that it's that in remote I/O configuration is only supported from the 5380, the 5069 controllers, or the 5580 control logics, L8 controllers. This is one benefit of using the chassis-based I/O in the distributed format would be a common platform throughout a facility. If the PLC platform is being utilized, has local I/O as well. For example, if you're using a control logic system, it could be beneficial to have the remote I/O on a common platform, so that can eliminate the need for extra spares or backups, and then have a common platform for engineers and maintenance techs to be familiar with one common platform. Moving on, a couple updates specifically to the 5069 or Compact 5000 I/O modules. Is one exciting release that's coming out very soon, hopefully, is the introduction of a brand new module. That's the isolated analog heart input and output modules. This release will give heart functionality to the 5069 platform. So it's going to allow for also in a channel-to-channel isolation for noise-sensitive application. Will obviously allow access to the highly integrated heart functionality, and that enables easy access to device health via enhanced diagnostics, and then will reduce engineering time with tight integration to Plant PAX 5.0 and above. Next update, some improvements to both analog input modules on the 5069. Firstly, with the IF8, improvements to the front-end circuitry, and some improvements to the channeling to eliminate common mode voltage, but namely the single-ended connectivity without changing the existing wiring. This is not a part number change or anything like that, just a series change from A to B, and those are now shipping. The IY4, the universal analog input, went through some similar changes and series change to reflect those same enhancements, and those are now shipping too. Next slide, please. Another big update enhancement on the 5069 platform that probably a lot of customers are excited about, I know I am, is an update to the OW16. Previously, the OW16 relay output module was powered through the system actuator power bus circuitry with 24-volt DC. So there happened to be a lot of cases where, if installed with analog or AC input modules, the OW16 could become damaged if it was not used in conjunction with an FPD module. It's undergone a redesign, so that's no longer a risk. So similar to the OW4 and OX4i modules, there's no need for an FPD should you be installing the OW16 in an AC input module system with AC power through the SA power terminal block. Next, moving on to some of our in-cabinet I/O options. So we have the capability of using our PLC family's I/O and remote, but we also have dedicated platforms for distributed I/O. Benefits from these families offer some varying levels of specialty I/O, including safety I/O, and variable form factors and features within these families. Starting with point I/O, this is a somewhat low-cost option for remote I/O, and very flexible with its small form factor, lower count on the I/O cards, but still a small form factor. These offer some specialty I/O, including I/O link support with a I/O link module. Next, we have 1794 Flex I/O. It's been a very popular platform throughout the years. Offers a flexible layout with high density modules. This is currently in the active mature life cycle stage, meaning that the end of life stage and discontinuation date is on the horizon. We don't expect it to be too soon, but it is on the horizon. These are still available for sale, but it's time now to start planning a replacement. And that replacement is the 5094 Flex 5000. As you can see from the pictures here, and we'll talk about in just a few minutes, a little more detail on the Flex 5000. Very similar form factor and system, with the only caveat being that the Flex 5000 is only supported in the L8 control logics and the 5069 compact logics. Finally, on our in-cabinet or distributed I/O platforms is the 1715 redundant I/O. This is typically for the process industry and oil and gas when high availability, process safety, and redundant I/O is needed, typically in a redundant controller setup. Next, we'll get a little more detail on the Flex 5000 family. With the Flex 5000 or 5094, you're going to see some performance enhancement, particularly with the communications with the 1 gig Ethernet and 1 gig backplane speed. We have all the typical standard I/O up to 32 channels on digitals. Point to note that there is 8-channel analog inputs, where in the 1794 we did have the IE12 that was a 12-channel analog input. With the Flex 5000, we also offer up to SEAL 3 rated safety I/O that can be mixed within the system with its standard I/O. There's a lot more flexible network topologies that can be used with the Flex 5000. I'll talk a little more about that in a second. They are hot swappable and a little more consistent on the I/O wiring compared to the Flex 5000. The module bases are all the same, and only a few different variants of the terminal blocks make it a little easier than it was with the Flex 5000 in selecting the correct ones. Next, we also have XT variants of the Flex 5000. So that's extreme environment. It includes conformal coating for corrosive environments, as well as a higher rated operating temperature. Both of these, the XT and standard, offer class 1 div 2 ratings. And next, please. And the installation options are flexible as far as mounting positions within an enclosure: vertical, upside down, right side up. And in addition to that, there's bus extensions available. So as I mentioned, in cases where you might be replacing a Flex I/O system and you need to add additional modules within the same space, you can utilize a bus extension to relocate different banks of I/O. Moving on to the available network topologies and the flexibility that exists there. We have our typical linear and star and DLR capabilities, but we also introduced the capability to utilize the PRP or parallel redundancy protocol network layout. And it's also worth mentioning here that the network adapters that are available have quite a few different options compared to what we had with the Flex I/O. We have different adapters that support 8 up to 16 I/O modules on one adapter. The standard copper ports for Ethernet, but we also now introduce the SFP capable network adapters, so you can go fiber direct to the network adapter, so you can increase speed, increase distances, and in some cases reduce the need for a media converter if fiber's within the network. Next, touching more on the PRP, the parallel redundancy protocol, and how that helps support controller redundancy and higher availability and higher resiliency networks. So PRP is more of a redundant network topology, typically used in redundant controller situations and process industry. So the high performance Flex 5000 family does support that network topology. So you can increase the availability and the performance of those redundant networks, specifically in the process industry with Flex 5000. And then finally, not finally, sorry, but just touching on the comparison between Flex 5000 and Flex IO, as you can see, the modules and adapters are exactly the same size. So it's the same exact footprint as the Flex IO. Similar terminal blocks, so that wiring is fairly consistent between the two families. So limited risk and limited effort there with a migration. On top of adding that capacity and system performance with the Flex 5000. Next, please. Some ways to help with this migration is a new tool that's been added to Integrated Architecture Builder, IAB. It's a free tool from Rockwell's product selection toolbox that helps with system design and layout, network design and system configuration. But there's a new tool in there that can quickly and easily, with a couple clicks, migrate your existing Flex 5000 or Flex IO to Flex 5000. Simply enter in your part numbers and system layout of your existing 1794 Flex IO. Click this button, brings up a dialog box to make some selections or changes. Confirm that, and then it can spit out a bill of material for everything you would need to replicate your 1794 system into 5094. And it's also worth noting here, some recent enhancements to IAB include the import and export of your Studio 5000 program via L5X. So what that means in the case of Flex 5000 migration would be you can simply import your existing program with a Flex IO system into IAB, build pre-built automatically how your system existing is, run through this Flex 5000 migration tool, pre-populate your 5094 Flex 5000, and then export that back to Studio 5000, where you can save yourself the pre-work and foundation building of that IO tree and module configuration for the new system. So significantly saves on some of that development time as far as programming goes. And with that, I think I'll hand it off to Mark.
Thank you, Neil. So the Flex 5000 and the Flex 5000 HA is the new Allen Bradley process IO. And these two sets of IO can only be managed by ControlLogic's, what we call the L8 processors, either the CompactLogic's 5380 or the ControlLogic's 5580 family of processors. These two sets of IO cannot be managed by the earlier ControlLogic's, what we would call the L7 processors. So that's important to note that the 5000, if you're going to use the Flex 5000 or the Flex HA 5000, you need a what we call the next gen processor or the L8 processor to do that. Next slide. So the Flex HA 5000 is meant for high availability. Currently, there's safety is not offered in this currently, but it will be in the future. And there's only one IO card available for this Flex HA because it's a universal IO card. It'll handle analog voltage, analog current, AC, DC. So there's only one IO card. These IO cards can function in either simplex mode or duplex mode. The wiring comes in to the rack. So when you purchase these, you purchase a rack, and then you purchase the I/O cards. It's a modular system, and so your sensor will come in to the rack and will wire directly to the rack, and it's actually the firmware in the rack that makes the transition over. If one I/O card fails, it immediately transitions over to the second I/O card. So this is a Flex HA5000, and it's meant for high availability systems primarily. You can use them for simplex systems. It is possible, but the main use of them would be for FlexPath, would be for high availability. So you can see here's the architecture of the system. You have the power conditioning modules where the power comes in. Notice there's two power conditioning modules. One fails, it fails over to the other. You have two Ethernet communication adapters in the rack. Likewise, if one fails, it'll fail over to the next one. You have rack extension cables, so you can extend the rack, and then you have the backplane modules, the I/O modules. You have simplex terminal block and duplex terminal blocks. If you have two sensors. So. All the diagnostics for this comes in through into the Logix processor. So you also have diagnostics. If one of the modules fails, then it'll fail over to the other module, and you'll get diagnostics in Logix 5000 that the failure has occurred. These can be mounted in virtually any direction, vertically or horizontally. They also utilize parallel redundant protocol communications. This is an important addition to high availability, to Logix high availability. In the past, we had high availability in terms of the processor, and we had high availability in terms of the I/O, but now we have network high availability as well. Here, the parallel redundant protocol is actually two networks, two LAN networks, two separate networks, and the modules determine the communication modules in the Logix rack and in the I/O rack. They get the packets, and they use the first packet that they get. So you could destroy the LAN A, and the LAN B would immediately handle the communication, and the failover time is 0 milliseconds virtually when this happens. So that's parallel redundant protocol. And then you can mix it up with the parallel redundant protocol. You can move the communications over to you can mix the LAN A and the LAN B communications to increase the failure on the segments. Of course, it'll handle device level ring communications. Device level ring, we can destroy one of the communication segments, and the ring will continue to operate. The heal time on device level ring is around 5 milliseconds, so it's bumpless. You will not lose any of these, PRP or device level ring, if you destroy the segment. It will the I/O is bumpless. You will never know that it failed over. So the 5015, that is the Flex HA that we're just now talking about. There are a couple of promotions that are being offered for this. One is a starter kit program, and so we could, if you have a need for these, and then there are commercial kits that are available. All right, so that is the process IO, Flex 5000 and Flex HA 5000 are the process IO. We move on to on-machine IO. For the on-machine IO, we have the 1738 Armor Point and the 1732 Armor Block. And both the Armor Point and the Armor Block can be controlled by any Logix 5000 processor. But the new product is the Armor Block 5000. The Armor Block 5000, you have to have a next gen or an L8 processor to control the Armor Block 5000. But these are on machine, and they're IP rated to 64 or 67. So, you know, you can spray them down, and these mount directly to the chassis of the machine. You can mount them in a cabinet, but they're designed to be screwed directly to the machine. So you can get your IO extremely close to your proximity sensors on the machine. The Armor Block 5000, it first came out as a IO Link Master, but since they have moved to offer a full line of discrete IO, they're configurable points on the IO. You can see that it's IP69K rated, so that would be high pressure washdown applications mounted directly to the machine. One of the advantages of this Flex 5000 is, and the IO Link, is that it has highly integrated IO Link. And what that means is in the Studio 5000, in the IO configuration, when you click on the Flex 5000 IO, you get detailed information of the IO Link sensor that is attached to it. You can see here, and it's manufacturer independent. So here we're looking at Bala and Rockwell sensors on this system. Festo builds IO Link products, and you would get that detailed information in Studio 5000. So the safety rated IO, we have a full line of safety rated IO. These IO would require a safety processor. So you would have to have a compact Logix or a compact guard Logix or a guard Logix, 1756 guard Logix processor to run these. We have block IO, Armor Block IO, safety IO that screws directly to the frame of the machine. We have the traditional 1734 point guard IO, and this is in cabinet IO, so this would reside in a cabinet. Here it's shown with the safety IO on the in the 1734 chassis, but 1734 chassis can handle regular discrete and analog IO along with the safety IO in the same chassis, so you don't have to devote the 1734 chassis to safety. You can mix and match as needed. In addition, we have the Flex 5000 safety. So Flex 5000, this would require an L8 processor. an L8 safety processor, and the Flex 5000 will handle both safety and regular discrete and analog I/O in the same chassis. Here it's shown with just safety I/O. It doesn't have to be just safety I/O. The Flex HA 5000, that safety I/O is in development. It has not been released yet. That release will probably coincide with the release of ControlLogic's redundant safety. And as I understand, it's scheduled for later this year. We have Compact 5000 safety I/O. The Compact 5000 safety I/O sits in the 5069 CompactLogix safety rack, and we have ControlLogix safety I/O 1756 I/O, and I must reiterate that in this diagram it shows just safety I/O in the rack. It doesn't have to be that way. You can mix and match safety I/O and regular I/O in these racks. The Flex 5000 I/O, the safety I/O comes in. They have an S designator on the end of the I/O module. We have the IB16S and the OB16S. These are also offered in extended temperature modules as well. We have an analog safety input module. We have an analog heart safety, and we have temperature safety as well. Yes. These all just dropped straight into Studio 5000. So that's kind of a look at the Flex HA and the Flex 5000 I/O. In addition, Spectrum Controls offers variants of all these I/O modules that you might find useful. Isolated analog. If Rockwell doesn't offer the isolated analog, then perhaps it's offered by Spectrum. So that's always a good place to look. And we have integrated condition monitoring. This is a piece of I/O that will monitor temperature and vibration at very high speeds. And then you can set thresholds in the I/O module to warn of or provide diagnostics about excessive vibration or excessive temperature. A lot of systems are aging out, so to speak, and we offer wiring conversion systems. So if we're going from an older system to like a PLC5 system to a 1756 ControlLogix system, we have wiring conversion systems. These speed up the wiring. They utilize the existing, say, PLC5 wiring terminal blocks, and so there's no rewiring. This is just plug in and move on. The wiring when you're using these conversion systems, changing out like a PLC5 to a ControlLogix is very fast. We also offer IFMs. In addition, Application Code Manager is a product, and it's already got all of the safety device library, I/O device library, power library, I/O link device library built into it. So this would be for reuse of code. And as Neil was mentioning about integrated architecture builder, if that's not a software that you're currently using, you should become familiar with it. It'll greatly simplify your life when you're choosing these products. But one of the big additions to Application Code Manager is the ability to export to Logix 5000, and then we can also import into Studio 5000 with these. So we can go both ways. We can develop an architecture and integrated architecture builder, and when we got that architecture like we like it, then we can export it to Studio 5000, and likewise, if we have a Studio 5000 project developed, then we can import that into integrated architecture builder. Next slide. And so that concludes our presentation for the day. Thanks everybody for joining.